Hi students, so I hope all the electrolytic cell topic is clear to you. The last topic which we need to cover here is cell representation. How do you represent a cell? Just remember the basic logic. How does the cell look like? You have to represent the cell in that manner. So you guys must be remembering there was two things here. Left and right component connected by a salt bridge, right? Suppose this is my salt bridge. So similarly, you have to write it like this. You remember left side oxidation was happening and then right side the reduction was happening. Similar ways you have to represent the cell. Like last time we did an example of zinc copper cell. So you must be aware that zinc was getting oxidized to Zn2 plus ion and your copper ions was getting reduced to your copper ion. So this is how you represent the cell. The final representation will be zinc getting oxidized to Zn2 plus connected to a salt bridge, then Cu2 plus is getting reduced to Cu. So this exactly is your oxidation half cell and this is your reduction half cell. So very easy to understand. This is how you represent the cell. Just remember the total number of electrons should be same. We'll just discuss this little later. Like one more example of cell representation I can tell you. Cr is giving you Cr3 plus in a salt bridge in between Pb2 plus is giving you Pb. This is one more example of how to represent a cell. Now in cell representation, one most important topic which you need to be aware of is the number of electrons should be same. The number of electrons should be same, or you can just tell the number of electrons should get cancelled. Should get cancelled, okay. Now, suppose you have zinc. Zinc is getting reduced to Zn2 plus 2 electrons. This was happening in your left hand side, like oxidation half cell, right? In the reduction half cell, what was happening? Cu2 plus 2 electrons was giving you Cu. Correct? Just combine these both. Can you see 2 electrons is getting cancelled at both ends? So now you get Zn, which is a solid, plus wherever you get ions, you write it in aqueous form. Cu2 plus aqueous, zinc in solid is giving you Cu in solid and Zn2 plus in aqueous condition. Zn2 plus in aqueous condition. This is how a cell reaction is written. As one more example I'll be giving you. I'll be writing the cell representation and you have to write the total cell reaction. Nickel Ni2 plus. Now here I am writing aqueous because it's an ion. Is giving Ag plus, which is aqueous again, and Ag, which is your solid. So how will you write cell reaction? Start from here. What is it? Nickel, right? What is happening to nickel? Nickel is forming Ni2 plus. How will nickel form Ni2 plus? By losing 2 electrons, right? So this is my first reaction. Then on this end, what is happening? Ag plus. See, always on right hand side reduction happens. Reduction means gain of electrons. So Ag plus only will accept one electron because there is just one plus, right? Will accept one electron to give you Ag. But what did we study? The major point, the major important point was the number of electrons should be same. Now can you see the electrons should get cancelled, but here you can see the electrons are not getting cancelled, right? So what we have to do, we have to do something. We have to modify the reactions in such a way that the number of electrons comes out to be same. How will that happen? What if I multiply by my second reaction by 2? If I multiply by 2, I will be getting Ag plus 2Ag plus 2 electrons is giving me 2Ag, right? Now if I combine this and my third reaction, combine the first and the third reaction, what will you be getting? Now the electrons are getting cancelled and you will get Ni plus 2Ag plus is giving you what is left? Ni2 plus and 2Ag. Na2 plus plus 2Ag, right? So this is an example of how do you represent a cell reaction and how do you represent a cell. The third reaction, one more example, just pause the video if you all want so that you can test yourself. Cr3 plus, which will be solid? This will be solid, this will be aqueous because ions are always in aqueous, will be giving you Pb2 plus. Pb2 plus is aqueous and Pb in solid. So how will you start writing the cell reaction? Start from the very left hand corner. What is happening to your chromium? Chromium is giving you Cr3 plus. Now since this is 3 plus means 3 electrons are coming out. And here what is happening? Pb2 plus is accepting 2 electrons to give you Pb, right? Now if you see here, both the side the electron number is different. So what we'll do? In order to make the electron number same, what we'll do is we'll multiply the first reaction by 2 and multiply this by 3. Why? So that the electron number becomes same. So what will you be getting? 2Cr you'll be getting 2Cr is giving you 2Cr3 plus 6 electrons, and here what will happen? 3Pb2 plus 6 electron is giving you 3Pb, and just combine these reactions. Then this 6 electrons will get cancelled. What is remaining? 2Cr on the left hand side. First see the left hand sides only. Plus 3Pb2 plus on the left hand side is giving you 2Cr3 plus on the right hand side plus 3Pb. So this is our overall cell reaction which needs to happen. So I hope everything is clear. We studied about the electrochemical cell. How does the electrochemical cell works? It converts the chemical energy into electrical energy. You have two components, the left hand side, the right hand side. Left hand side the oxidation happens, right hand side the reduction happens, and the flow of electrons was from anode to cathode. The flow of electricity was from cathode to anode. This is how the electrochemical cell works. Then we studied something about salt bridge. Why salt bridge is important? Because it is maintaining the electrical neutrality of the solution. There is no liquid-liquid junction potential and it allows the flow of the electrons. The very next thing which we studied was the cell representation and the cell reaction. Left hand side you have to write the oxidation happening, right hand side you have to write the reduction connected by a salt bridge, and eventually you need to make the electrons balance, so you can write the cell reaction also. I hope everything is clear at this point. Next topic what we'll be studying is your electrode potential. What is electrode potential? How does it work? And from this we'll be studying Nernst equation. So if you have any doubts, you can mention it in the comment section. And thank you so much.